Hey guys, it's Someone9031 here, and today I will be continuing where I left off in the last tutorial by continuing on with my explanation of operator overloading. Now, in the last tutorial, I introduced you guys to basic operator overloading by teaching you guys how to overload these three operators: the addition operator, the equality operator, and the assignment operator. Now today we will start by looking at some unary operators that we can overload. And unary operator basically means an operator that takes only one operand. The three operators I showed you last week were all binary operators. They all take two operands. They operate on two different objects. So the unary operators that we will be looking at today are the increment operator, the decrement operator, and the unary negation operator, which is the operator that will turn the object into its negative counterpart. So let's get started. We will start off with the increment operator, which is ++. And because these are unary operators that we are defining as member functions, they will not take any arguments because it operates on one object, and that object is the one that the operator function is being called on. So nothing is passed in through arguments. Now let's do decrement and negation. Okay, so let's go down here and start defining those. Now, what we want to do here, what we want this operator to do is, of course, increase our num variable by 1, which is what happens with integers when you apply them. So, what we want to do is make my class MC, and we're going to do num plus 1 and we're going to return MC. So that is what our operator will do. When we use this operator on an object of the type myClass, it will take the num variable, it will increase it by 1, create a new object storing that value, and return that new object. Now, it will be similar for decrement because they basically just do the reverse of each other. So my class MC num minus 1 return MC. Of course, you could do this all in one line as well. You could just do return my class. You could just do this, return my class num minus 1. And what this will do is create a brand new object with this value and return that object. Now let's do negation. Operator minus return my class MC negative num, because the unary negation is already defined for integers, so we can just do that. And now we return MC. So yeah, it's just that simple. It's not a terribly hard concept, operator overloading. It's just very confusing, and it sounds like a much better idea than it actually is, because these operators rarely come into play. They rarely overloaded. They don't have too much use, except like I told you in the last tutorial, the one that you should overload, the one that you will most commonly overload will be, of course, this assignment operator. And you will do that whenever a shallow copy is not desired, whenever you require a deep copy of the object instead of performing a shallow copy. So basically the rule for overloading the assignment operator is whenever you define your own copy constructor, then you should also overload your own assignment operator. As for the other ones, you should probably hold off on operator overloading for a while until you're very comfortable with the rest of the C++ language. Then you can start doing operator overloading again. It's not a terribly good idea. It's prone to errors and stuff, especially when you have much bigger classes, because this one, the only thing we were modifying is that one variable there, so that's not too bad. There's also one other operator that is commonly overloaded, and that is actually the subscript operator, which is which you use for accessing arrays. So it's used mainly for container classes. So here I have defined my own container class that will hold an array of integers. It's called int array or int r, whatever you want to call it. Constructor is one constructor only. It takes an integer, which is the number of elements to have in the array, and it will allocate that memory. We should probably also have a deconstructor here. So let's just do that right now. So delete ARR. Actually, because it will be an array, we'll be deleting the entire thing. There we go. So that is our destructor there. Now, because we want this array class to operate just like a normal array, we will need this subscript operator so we can access a particular index within this internal array. So we overload that operator. It will return an integer reference because we want to be able to modify the value that it returns, and it takes one argument, which is the argument that you will see within these square brackets. So down here, and what we want to do is return that particular index within the internal array. And we actually want this to be more safe. We don't want to be accessing past the array. So what we want to do is check if index is within the boundary of the array. So if, let's see, index is smaller than size, and index is, let's see, greater than or equal to 0. So we only want to do this if it's smaller than the size and greater than 0. Otherwise, we don't want to be accessing that array at that particular element because it is past the boundary of the array, and we'll probably do something bad that we really don't want. And now we can just use this like a normal array. So int arr, let's see, a, and we'll make, say, 6 elements. And then now a 0 equals 4, a 1 equals 134, a 2 equals 2467, and so on. We can just use this like a normal array. We can have int I equals a 2. So basically we can use this like a normal array. We can print it out because this returns the particular value stored there. So we can print it out. We can also print out I. Now I can run our program and yeah, look at the results. Alright, here we go. And now it says 434, 2,467, and 2,467. So that is basically the subscript operator. Both this and the assignment operator are the two most commonly overloaded operators. This is usually only for container classes, which are classes that store values, basically arrays. Yeah. We can also do greater than, less than, greater than, equals to, equal to. It'll be sort of like equality, except we won't be checking for equality. We'll just be checking if it's greater than or less than or whatever. Also, an operator for a class that you are overloading can also be defined instead of as a member function. It can also be declared as either a friend function of that class or a global function, which is the normal functions that we use to write. So, as an example, I will be overloading another operator plus for this myClass class. I'll be overloading another addition operator, but this time I will be using a global function. Now, with a global function, most things stay the same. You put your return type, and then you put operator, and then the operator. But now, because while it was a member function, the operator was always called on an object, and that object was always passed in as a this pointer, which meant that only one argument was needed for a binary operator. But now, because this is not a member function anymore, the this pointer will not pass in anything. It doesn't. The this pointer will not exist. So we need to pass in two objects of the myClass, of the form myClass. Like so, and then now myClass mc.num plus mc2.num return m, like so. Now there's two, except for this one, because everything stays the same, and we now get an error here because now we have two operators that are exactly the same. So we're going to need to change this. You can also overload operators that will operate on two objects of different types. So for example, we can overload an addition operator that will add together, say you had two classes called A and B. We could overload an operator that will add together two objects of A and B. So one A object, one B object. And I will demonstrate this right now by changing this into an int, which is a built-in C++ type. So int I. So now we can have an addition operator that will add together a myClass object and an int. Now there's one more thing I need to show you. You can also you can overload these operators as friend functions, which is exactly the same, except you just need to include it inside the class declaration. I showed you how to do friend functions in the last tutorial. Now, one last thing, you can also overload conversion or cast operators, which are operators that will convert an object from one type into another. For example, you can convert an int into a double, or a double into an int. That's built-in C++ functionality. But you can also overload conversion operators for your own classes. So the syntax is very similar to normal operator overloading, except that there will be no return type. If you put a return type, it will be a syntax error. Instead, you just put operator, and then after that you put the whatever type that you want to convert to. So you could put like double, but in this case I will do int, and then just follow that with 2 parentheses, nothing inside. Now we can go out here and do my class operator int. And also, because conversion operators usually should not modify an object, you should also flag these as const, which means constant, so they can't change anything. And then now what we would just want to do is return num, because if you remember, this is a member function. It passes in a this pointer, so we just basically return the num. Now we can do like my class C equals 4, and it will automatically convert the 4 into an object of my class. Okay, so yeah, that's it for this tutorial. If you like this video, please subscribe, rate, and if you have any feedback, comments, or questions, please feel free to leave a comment in the comment section below, or you can message me on YouTube. Thanks for watching.